Okay, good morning, everyone. In today's lecture, we'll start with the triple integration. In the previous lecture, I have already given some of the introduction part, using which we can actually understand the graphical meaning of the limits and triple integration. So, most of the things are going to be clear now. So, we'll start with the example where the limits are already given and we are just supposed to find out the integration. And then in the same example, what we'll do is we'll actually try to draw the graph. As it is three-dimensional, it will be quite difficult to imagine in most of the cases, but still we'll try our best. The example is evaluate integration minus 1 to 1 0 to z x minus z to x plus z x plus y plus z dy dx dz. So I want you to tell me this minus 1 to 1 is the limit for which variable? Minus 1 to 1 is the limit for
So Z.
Z.
z, exactly. Then this is the limit for
For X.
x, exactly. And third one is for y. Okay. So let's solve this integration. Just like we solve the double integration in the same manner, we have to proceed for the triple too. So the first integration is with respect to y. So this is going to be xy. Okay, what we will do is we'll consider that as a bracket x plus z. So what we will have x plus z into y plus y square divided by 2. Limits are from x minus z to x plus z dx dz. So now as we put the limits minus 1 to 1, 0 to z, when we put the upper limit, so what we will have is x plus z square plus x plus z square divided by 2 minus x square minus z square minus x minus z whole square divided by 2. Bracket complete dx dz. Well, the integration is possible with respect to x. Okay, so x plus z square, if we integrate, that will be actually x plus z cube divided by 3, right? Then the next term is going to be, you can simplify this actually, this will be x plus z. Uh, 1 plus 1 by 2, actually 3 by 2 x plus z square. So integration minus 1 to plus 1, integration 0 to z in the bracket, this will be 3 by 2 x plus z whole square. The next term is going to be, so We can simplify this somewhere else. So minus x square plus z square. Okay. Take the integration. So minus of x square minus z square minus x minus z square divided by 2 bracket complete dx dz. Now the integration with respect to this is integration minus 1 to plus 1. We integrate this, we'll have 3 by 2 x plus z cube divided by 3. If we open the bracket, we have the integration with respect to x. So this will be minus x cube divided by 3. This will be plus z square. So we'll have plus z square x. And the third term is minus of x minus z whole cube divided by minus 3. X minus z cube divided by 3 actually. So 3 into 2 is already there. So this will become 6. Limit from 0 to z. Dz. So this is the integration minus 1 to 1. When you put the upper limit, so you will have 2z there. So 2z cube, that will be 8z cube, 8 by 2, which is 4. So totally we have 4z cube. In the second one, minus z cube by 3. Next term is plus z cube. And the last one, z minus z will turn out to be 0. You can see that x minus z is there. So that term will become 0. When you put the lower limit, the value of x is 0. So what we have is z cube by 2. Let's check the calculation. Minus z cube by 2. If you put x as 0 in the second term, it will turn out to be 0. Even the third term will become 0. And the fourth term, that will minus z cube will become plus z cube divided by 6. Bracket complete dz. Which is all the terms are in z cube, so we can add them, add, subtract, whatever. And the final thing, so 4 minus 1 by 3 plus 1. 1 minus 1 by 2. So that will be 1 by 2 plus 1 by 6. 13. So that will be 13 z cube divided by 3 dz. What is the answer for this? Anyone? You should be able to give the answer orally here.
When 26 by 3.
13 z की power 4 by 12.
No, no. I want the final answer. You have given J. You should be
Zero.
able. Yes, exactly. Why 0?
The limit is minus 1 to 1 and there is even power.
Odd power.
Yes, sir, odd power.
This is 0. This function is an odd function. So f of minus z is equal to minus of f of z, and the limit is from minus a to plus a. So the answer is 0. Okay, so when the limits are given, it is very much, I mean, just calculation is something that you have to do. But if the limits are not given, and in that case, we will have to draw the graph, and from the graph, we will actually have to define the limit. Okay. So for the same purpose, what we'll do is we'll try to solve an example in which the limits are not provided, and then we will see how to give the.
Excuse me, sir.
Yes.
Sir, can you go back to previous slide, please? So here we haven't integrated with respect to z. Then if we do that, then it will become even function, no? Z की power 4 will be there.
Let it be ना, इंटीग्रेशन के बाद में क्या आ रहा है उससे मतलब नहीं है हमें. What I am seeing is integration minus a to plus a of an odd function f of x. The property of the 12th standard minus a to plus a f of x dx. If the function f of x is odd, then what is the answer? 0.
0.
है ना. तो इंटीग्रेशन किया है हमने, बट वो प्रॉपर्टी से डायरेक्टली आंसर बताता है. इफ यू गो बाय योर रेगुलर मेथड, if you try solving it, making it z raised to 4 by 4 and putting the upper limit, lower limit, finally you will get the answer 0. Okay.
Yes, sir.
Next example. Integrate triple integral x square yz dx dy dz over the volume bounded by x equal to 0, y equal to 0, z is equal to 0, comma x by a plus y by b plus z by c is equal to 1. Okay, I'll change the question a bit. What is this? X by a plus y by b plus z by c equal to 1.
Sir, equation of line.
Sir, equation in the intercept form.
Equation of what in intercept form?
Equations of line in
line.
intercepts form.
What we have done in the previous lecture was a complete waste if you are not answering properly to this. The equation of line, you had x by a plus y by b equal to 1.
Sir, plane.
Plane, sir.
So that was a plane. Now we have to integrate this over the volume bounded by x equal to 0. What is this? X equal to 0.
The YZ plane.
YZ plane. Y equal to 0 is XZ plane and Z equal to 0 is XY plane. So you have 3 planes and then you have x plus y plus z equal to 1, which is another line or plane. X plus y plus z equal to 1. It's a plane. So we are given 4 planes and we need to find this integration over the volume which is bounded by these 4 planes. How many points are enough to find out a line? If I want to draw a line, how many points should I know on the line?
2
So
points.
3.
2 points.
2 points. So if you know any 2 points on the line, you can draw the line. So when I'm thinking of a plane, how many points are needed?
So 3.
Is there any condition on the 3 points?
No, sir, no condition.
No condition. Non-collinear. So if you give me 3 non-collinear points, we can always draw the plane. So what I'm going to do is I'll find out 3 non-collinear points on this plane. And how can I do that? So I will put y equal to 0, z equal to 0. This will give me which intercept?
X equal to
X
1.
intercept.
This will be x-intercept. So we have a point 1, 0, 0 on x-axis, which lies on this plane. Then I will put x equal to 0. Am I audible? Hello.
Yes, sir. Yes, sir.
So I'll put x equal to 0, z equal to 0. In that case, we'll get y equal to 1, which is y-intercept of this plane. So 0, 1, 0. And then we'll put x equal to 0, y equal to 0. When we put these values, we'll get z equal to 1, so which is z-intercept. So we have 3 non-collinear points which lie on this plane, and I will join these points in order to get the plane. So we have a structure like this. And what does the question say? You have to find this integration on the volume which is bounded by xy plane, yz plane, xz plane, and this, the last one. Okay. So in order to understand this, look at the actual graph. So we, what I have done here is, so I will put the equation x equal to 0, y equal to 0, z equal to 0. So you can see that we have got the planes. So xy plane, yz plane. So if you see, the middle part is the triangle that you prism type of structure, not prism, tetrahedron type of structure you have got. So this tetrahedron, which is bounded by all these 4 planes, the middle part there, which is bounded by the coordinate planes and the plane x plus y plus z equal to 1. So over that region, I will actually have to integrate. So in double integration, what we did was we made a strip. Okay. So we made a strip which is parallel to x-axis or y-axis. Okay. What I need to cover now is I need to cover a volume. So what I should do is I will consider a pillar. So I will consider a base plane first of all, over which I'm going to integrate. So this is the volume over which I need to integrate. I hope all are convinced with this. Now the volume which is bounded by these 4 planes is this. Now what I will do is I'll consider this base. This as the base which is on the xy plane. With a strip parallel to x-axis or y-axis, I can cover this. Am I right? And then once I have covered the ground, I need to cover the volume. And how do we cover the volume is, I'll consider a pillar. I'll consider a pillar which starts from this base and it goes up to the upper boundary, whatever we have. Look, the idea is simple now. You'll cover the ground with the strip parallel to x-axis or y-axis, and on that ground you consider the vertical pillar. When you consider the vertical pillar, it will give me the value of z, as you can see. So this is the complete idea when you want to integrate in Cartesian coordinate system, a triple integration. So my question is, to consider a pillar on xy plane and a strip parallel to y-axis on xy plane in the region. So this all has to be done in the region. Now I will start with the ground. The strip is parallel to which axis? Y-axis. So which limit has to be fixed now? Please respond, or else you won't be able to understand this later. There can be asked a lot of MCQs that give the limits for this, and you won't be able
The
to do it
limits for
later.
x.
So limits will be for x. So x is running from, you move the strip, the
0 to
movement of the 0 to
1.
1. Exactly, very good. So as we move the strip, so x will be going from this value to this value, which is the point A100. Then what about y? So y, we can see that the strip starts from this x-axis and ends at this line. So this line is actually the intersection of the plane x plus y plus z equal to 1 and the xy plane. On xy plane, what is the value of, what is the equation of xy plane? Z equal to 0. So this line has to be, anyone? So I will write it down here if you haven't listened properly.
So x plus y equal to 1.
Line is, yes, exactly, is intersection of the plane x plus y plus z equal to 1 and the xy plane. The xy plane is z equal to 0. So equation of line क्या हो गया? X plus y equal to 1. So what will be the limit for y? The strip starts from y equal to 0 to y equal to 1 minus x. Now let's talk about the pillar. Your pillar starts from, now your pillar starts from xy plane. On xy plane, what is the value of z? That is 0 to, the upper limit for z is, it goes up to the plane. From the equation of plane, find out the value of z. It is from the equation of plane, find the value of z.
One minus x minus y.
1 minus x minus y. So what have we got? We have got integration. So I is equal to integration 0 to 1, 0 to 1 minus x, 0 to 1 minus x minus y, x square y z, will have dz dy dx. We won't solve it further. I won't go for solving it, as solving is very easy. Okay, so I will leave it up to you. How do you solve it and how do you go ahead? Take 2 minutes, try to understand everything which is on your screen right now. If you have any difficulty, ask or we'll go ahead.
So how does the pillar move exactly? Like, does it move along with the strip?
Yes. So move needs to move on the strip. Whole of the ground has to be covered by the strip, by the pillar. Okay. So if it is moving whole on the ground, so at each point you can see that the height of the pillar is going to vary, and the base is same, which is the XY plane.
Okay, sir.
So, sir,
Sir,
where the strip is longest, like on the y-axis, the pillar will from move on the xy line, right? On the xy plane, sorry.
Yes. If you change the plane which you are covering, if for an example, I wish to take the strip on this XZ plane. My XZ plane is this one. On this side, if I take the strip uh, on this side, I'll take the strip parallel to say Z axis. Then you can think of the limits, which are going to be a bit different in that case. So if I take the strip parallel to Z axis, the strip will be like this. And once I have covered this plane, my pillar will start from this plane and it will come to this side. Okay. So if I do this, then you can see that the value of x is going from 0 to 1, 0 to x equal to 1. By the strip, the value of z is going to be from 0 to this line, which is on xz plane. On xz plane, y is 0. So z is equal to 1 minus x. What about the pillar? Pillar will go from y equal to 0 to y equal to 1 minus x minus z. So it's up to you which ground you need to cover first and then take the pillar.
sir, pillar will move in 3 dimension.
Yes, pillar is a 3-dimension thing.
Sir, you said equations of xy plane is z equal to 0.
Hmm.
Sir, how it is?
Collect the points which are having z coordinate as 0. What you will get? When you say that x square plus y square equal to 1, what you are actually doing is you are collecting the points which will satisfy the equation x square plus y square equal to 1. Y equal to x square parabola क्यों है? The reason is you collect all the points which satisfy the equation y equal to x square. So I am saying that when I say z equal to 0, you collect all the points which will have the value of z coordinate as 0. So what you will get is what
Xy
is
plane.
that is the reason why I say z equal to 0 is xy plane. Okay. So in three-dimensional space, lot easy things can happen, and that can be done by the different coordinate systems which we have studied in the previous lecture. So if you have a complete space, or if you are integrating inside a sphere, if you are integrating inside a paraboloid, or you are integrating inside a ellipsoid. So in all those cases, what we do is we use the different coordinate systems and we find out the integration. So I will solve an example on the same. So evaluate triple integral dx dy dz upon under root 1 minus x square minus y square minus z square. Take then throughout the volume of sphere x square plus y square plus z square equal to 1 in post or sorry positive octant. Yes, anyone? What logic you can give behind the word positive octant? So anyone who is going to have a
the
good
first-
imagination,
So in the first quadrant,
what do you mean by quadrant here?
So all the positive sides of x, y, and z axes.
And why is the word octant there?
So of course there are
so because the
eight
Cartesian system, so the
2D in
Cartesian
2D plane
system,
is there is a fourth quadrant, but in 3D it's double.
so in
Okay.
three-dimensional Cartesian plane,
Yes.
it can be divided into 8 octants in all, and among them, the positive octant will be the first quadrant. That is the positive sides of all the axes.
So
Yes, sir.
when we are in a three-dimensional space, you can just think of your house, and you can think that the walls are going to divide it. So you can see that the whole of the space will be divided into 8 parts when we are in three-dimensional space, and the 8 is nothing but octa, right? So each part is called the octant, and positive octant, as Yash correctly said, that the positive octant is where you will have all the three variables positive. Okay, so x positive, y positive, and z positive. So we know that here in the first octant, the positive octant will look like this. So this is the part over which we are going to evaluate the integral. If you compare this with your double integrals, in the double integral, when we have Cartesian coordinates, so we had the strip parallel to x-axis, y-axis. When we move to polar, in polar coordinate system, what we did was we made the strip which is starting from the origin and ending at our curve. In the similar manner, in three-dimensional space, our pillar is going to vary depending on the different coordinate system. In the Cartesian coordinate system, our pillar was parallel to x-axis, or we are making pillar parallel to y-axis, or we are making it parallel to z-axis. So in the spherical coordinate system, now whenever you are going to see a sphere, you need to think of spherical coordinate system. We have already studied this. When we are dealing with spherical coordinate system, what we need to put is x is equal to r cos phi
Sin theta.
r sin phi, and then you have sin theta in both the cases, and then we have z is equal to r cos of theta. So this is what we need to substitute. The reason why is for spherical coordinate system, x square plus y square plus z square becomes r square. You can actually put the values and you can check that. So whenever we will have this type of integration, so x square plus y square plus z square will simply turn out to be r square in spherical coordinate system. With this, what is the significance of r? R is the distance from the origin, is phi. Phi is the angle made on the xy plane, and theta is the angle with positive z axis. So from the figure, what do we have? What are the limits for r, theta, and phi? So the pillar will start from the origin and it end at my surface. This is the surface over which we are working. So what is the minimum distance from the origin for your volume, and what is the large maximum distance that you will have?
So 0 to 1.
Exactly. So r is running from 0 to r is equal to 1. What about phi? What is phi? The significance of phi. If you see and if you try to understand it, you will be able to give the limits for phi. Yes,
0 to 90.
0 to pi by 2.
0 to pi by 2, exactly. So limits of phi from 0. What about theta? So how much maximum angle this pillar can make with positive z axis?
0 to pi by 2 again.
0 to pi by 2. One more thing we need to replace. When I'm changing the coordinates, I mean x, y, z, now after substituting these things, I will have r, theta, and phi. So dx, dy, dz, this is replaced by what I said in the previous lecture while we dealt with this polar. Dx, dy, dz will be replaced by, what was the formula? Dx, dy is equal to, think of polar. You'll be able to relate it with spherical coordinate system. No one? The formula was whatever new substitutions you do, so dx, dy, dz will be replaced by Jacobian of x, y, z with respect to r, theta, and phi. Okay, so this is the idea. Whenever you are going to make the coordinate change from one to other, so this is the standard formula. Now, for spherical coordinate system, this Jacobian is r square sine theta. This you will have to remember. After this example, I'll give you the remarks for the Jacobians too. So, dx, dy, dz will be replaced by r square sine theta, r square sine theta, dr d phi d theta. So we have completely changed the coordinates. So r is running from 0 to 1, phi is running from 0 to pi by 2. Theta is running from 0 to pi by 2. We'll have 1 upon under root. Yes, what will be that?
One
What?
minus square
1 minus
r square.
r square. Exactly. How can we solve this integration? In 2 steps. I'll rub the diagram now. How to solve the integration? Anyone? Yes.
Put r equal to
No. I want the smartest way to solve this integration.
take r common, r square common.
So we can see that the limits are constant, and if you look at the integrand, even the integrand is the product of r square upon under root 1 minus r square. Then you have sine theta. So you can write the integrand as the product of the functions of those 3 variables. So what we can actually do is, by the property, we can directly separate and find the integration separately. R square upon under root 1 minus r square dr. Then integration phi is running from 0 to pi by 2 d phi. And the third bracket, integration theta is running from 0 to pi by 2 sine theta d theta. This is the property that we have seen. First bracket, I will leave it for you to think how can we find the integration. The second one is pi by 2. Third one is minus cos theta, 0 to pi by 2. 0 is 1. So the answer there is 1. What about the first one? Quickly.
Add and subtract 1 in
Why?
the numerator.
Why? You have learned so many techniques now.
Sir, we can carry out substitution.
R is equal to sine theta.
Sine square, sine theta.
So dr will become cos theta d theta. For 0, r is equal to 0, theta is 0. For r equal to 1, theta is pi by 2. So integration 0 to pi by 2 sine square theta. Denominator में 1 minus sine square will become cos square. So cos theta will be in the denominator and this cos theta. So 0 to pi by 2 sine square theta. What is the answer for this? 2, 1, pi by 2. I hope you know this. 2, 1, pi by 2. What is this? How do you get this? Rohit,
Sin n theta formula.
so this is the reduction formula that I have used. So this pi by 4. Look up the calculations. So the final answer is pi by 8. Pi square divided by 8. So in the next lecture, what we'll do is we'll solve some examples where we need to use spherical coordinate system. Somewhere we will have to use cylindrical coordinate system. In some example, we'll have to use ellipsoidal coordinate system. So those examples we'll solve in the next lecture. But before that, we need to remember the Jacobians for each and every coordinate system. So I will write down the remarks and then we'll stop. So the remark first one, for spherical coordinates dx, dy, dz is replaced by r square sine theta and dr, d theta, d phi. Second, for cylindrical coordinate system dx, dy, dz is replaced by rho, d rho, d theta, dz. If you are substituting x is equal to rho cos theta, I'll just recall this: x is equal to rho cos theta, y is equal to rho sin theta, and z is equal to z. This is what cylindrical coordinate look like. The third one that we saw was the ellipsoidal coordinate system. So for ellipsoidal coordinates, dx, dy, dz is replaced by a, b, c, r square sine theta, dr, d theta, d phi. So these are the replacements depending on the coordinates that you are using. So here I'll stop. If you have any difficulties, please ask.
Sir, actually, I had a doubt.
Hmm.
In the TUT which was conducted on Saturday,
Hmm.
the first question of it.
What is the doubt?
Sir, I was not able to solve the first question of it.
Okay.
Like I was able to solve, but I don't know the method is correct or not.
Okay.
Can you just?
You're from division 18, na?
Yes, sir.
Yes, sir. Even we had problems in that.
Okay. I'll post the solution of that question.
Okay, sir.
16 have also had problem in first question.
Okay.
So after that we write a matlab a shortcut direct answer.
Okay. Fine. I'll give the solution for it.
Sir, actually, giving the solution is good, but can we just solve it right now, please, sir? I can
Sir,
tell you the question.
there is class next lecture at 10:45. So please.
10:45 है ना उत्कर्ष?
Yes.
Wait. I'll put the attendance, so whoever wants to leave, they can mark their attendance and leave.
Sir, please minimize this window.
So the question is this, that is polar. I don't know why. Oh, it's difficult to answer it.